All right, folks. Please, can you see Raspberry Pi? Meet the Raspberry Pi microcomputing. Raise your hand if you can. I am broadcasting out of a hotel room. We had a bit of a personal family issue that has come up, and so I'm at a new location just for tonight. Okay? So I hope everybody's doing well. Let's just check here. I'm going to check our calendar. We'll wait for everybody else to get in here. Bear with me one second while we wait for everybody to get here. Okay, this week is for people that meet on Saturdays. We've got lab this week. So Saturdays we have lab. Okay? For those people that have the Saturday lab, remember we have this week, you're going to be making the infinity mirrors. So that's what we've got going on next. Okay? And then let me see what we. All right. And then next Tuesday will be our next Tuesday night, or this Thursday, I should say, is this Thursday's our 7 to 9 lab. I'm just going back and looking at what we have going on. I'll confirm that. Sorry, let me confirm on Thursday. So we just had lab Tuesday, so let me just make sure. Okay? Any questions on right now? Raise your hand if you've got a question. All right, now, so we're going to record. We'll post everything up tomorrow night probably. Okay, let's just go back. You should have at this point, I'm going to turn that off because it apparently messes this up. We're going to jump out of that. This is what we use. Were you going through your Raspberry Pi tonight? Raise your hand if your Raspberry Pi you know for a fact works now. Should have worked with Tom a little bit on this. We just want to make sure. Okay. Okay. So, all right. So Grayson, does yours work? And you don't have your hand up, or what's the issue? We want to make sure. We're going to do some things. You don't need it quite yet, but pretty soon we are going to need these. All right. Go ahead. So, just about everybody's gotten it up there. Joshua, Mateo, let us know if there's a problem, okay? And we'll watch for it. I'm going to look at the questions here, see if you. Hello, hey. Is there anything we might want to bring to Saturday's lab? Just a good attitude. You don't need to bring your Raspberry Pis. You're going to be working on Infinity Mirror with Mr. Rudolph, who knows very knowledgeable, and Sarah Gibson, as well as Mrs. Dubik. I'll be in Raleigh working with the kids up there. Okay. Laura, you can't make it. I understand. We'll try to record it. I won't be able to load it till tomorrow. Okay. And if you can't make it, then go ahead. You can, Thursday, we'll try to create you caught back up. I will check on the labs. Okay. Now, we've got that. So most everybody's got them working. Don't worry about it. Just make sure your Raspberry Pi works. So when we get to that point, we say, okay, tonight, have your Raspberry Pi up and running. We're not running around here. Tonight is going to be a couple things. We're going to learn about using Raspberry Pi. And the language we're going to deal with is Python, which is a very useful language. It's used quite a bit now. And we're going to do that through Code Combat. So for some people have seen Code Combat, some people have not. We'll do it real quick. Put everybody's hands down. Let's see. If you've done Code Combat, raise your hand. Okay, have a few, but most everybody has not, so that's great. It's a great way to be introduced to Python. We can also do Code Academy. Also, let me give you a tip now. If you're you live in Charlotte-Mecklenburg area, Get your library card, and there's a thing called Lynda out there, and Lynda is an online tutorial service. It's free if you have a library card. So I highly recommend that. I don't know up in Raleigh. We could check up there and see what you folks have, and in Winston-Salem and Hickory. But I do know we have it in Charlotte-Mecklenburg. All right. Let's go ahead, putting everybody's hands down. This can be kind of a laid-back lecture as we go through this Raspberry Pi, but I want you to make sure you all understand the parts of it. It's a full, as you know, it's a full functional computer. That's what makes the Raspberry Pi great. It's now fast enough you can surf the net with it. It uses Lexus operating system called Raspbian, which is really based on Debian. If you know Debian, you're going to know Raspbian. All right. This is the same, by the way, in case you wonder about this presentation. I use this presentation. There is a Raspberry Pi competition this year in Science Olympiad, and we'll be using these same slides. This is an element 14, but it gives you the dimensions of it. And really what 4 USBs, 10, 100 LAN. So if you've got a LAN at home, I really recommend you run it over that as opposed to Wi-Fi. It's always a better choice, almost always. Audio output jack, camera port if we want to hook a camera up, HDMI right there connection, micro power, another type of digital display, don't really care, SD, onboard Bluetooth, and it used to not have this, as well as Wi-Fi. Broadcom 1.2 gigahertz, 1 gig RAM. That's a great thing. It's just like Moore's Law. The power of this chip keeps increasing. The price stays the same. Moore's Law for years was just getting the computers faster, more powerful for the same price. Now what's starting to happen is the computer only needs to be so fast to be a word processor. So let's just drive the price down. And it's been a really amazing thing. You got a 40 pin right here. Here's dimensions to hook it up. So you can connect it. You see those little connections here and here. So you can connect it to a board. Now, remember when you set yours up, put your SD card on, put on your mouse and keyboard, come all the way around. If you've got a LAN, hook it on there. Then your HDMI cable, then your power. SD card, power last. When you're taking it down, take the power off first. Make sure you do shutdown. A lot of Linux machines, you can just turn them off. Any questions there? Raise your hands. So there it is, that Broadcom. So let me go ahead there. Yeah, let me show this back to you. So that was the chip. See with the black line there. There's USB ports, LAN, camera, power input, which you all know at this point. And there's an SD slot. And our Wi-Fi. And I'm going to move this over so you can see it. With Bluetooth and Wi-Fi already baked in. Let me just stress that again. Sorry. All right. SD card comes operating system. I set that up for you. So in case you're wondering, hey, those SD cards, it's not that hard. You download them. You need a 5-volt power supply, which is, you find that anywhere, and HDMI connecting to your TV, keyboard and mouse. All right. And we mentioned this last week, just going through it again. Step 1, put it in your SD card. 2, plug in your keyboard and mouse. 3, plug in your HDMI. 4, power that bad boy up. All right, and simple size task field manual. We did that in school. All right, now on the home screen, if you turn this thing on, when you go to play with this later, and if you've got it on, oh, great. If you don't, that's okay too. You're going to see it has a nice ocean view. They keep improving the graphics and things on this every time I use it. All right, let me go over here. So there's your menu. And here's all the programming languages. And they change from time to time. But you can see them all when you go into programming. They'll have a whole list. Well, we're going to be using Python 3, folks. But you're going to see, and we're going to talk about these, each one of these. Okay? They also have Office. You can do all your word processing, everything on it. It's very similar to Office. There's, calculator, draw, impression, math, writer, all right there. Then under Internet, you have F&E web browser. You go Raspberry Pi resources automatically give you. It'll give you Magpie. If you're looking for cool, interesting things to do, read Magpie. They have all the old subscriptions. It's amazing. You have Minecraft Pi and Python games. And Minecraft, we used to go ahead and hack that all the time with Python. And you got accessories that you would expect on any computer. You've got calculator, file manager, image viewer, PDF viewer, SD card reader, task manager. We'll get into these. Terminal, text editor. All right. Help, Debian reference. Can be a little esoteric to read, but it's all there. Just going to have to dig through it. And then preferences. This is where you can play with all things and make the Raspberry Pi yours. You know, how it looks, add software, appearance settings, all that good stuff. So up at the top, you have a quick. There gives you access to internet. I can't stress it enough that this is now a good browser. So hook it up at home, figure out a way TV. You got internet. As long as your folks are fine with you being on the internet every time. All right. File management, kind of like a Windows interface access that you would expect. Terminals when we want to get back and write some nice Linux code in there. So that's good for that. There'll be times down the road we might use that. Mathematica and Wolfram, frankly, are the same program. They're a sophisticated search mathematical engine that you can use out there. All right. I'm not going to use it a lot right now. All right. At the top right-hand menu of it, you have Bluetooth, your wireless, sound, how much CPU usage. If you're doing something and you're saying, man, I'm wondering if I'm bogging down this computer, look on your CPU usage. Time, and of course, eject the SD card. Okay. Now let's take a closer look at that programming. Well, first one is BlueJava IDE, Java for older students. Guys that are getting into Java, it's a great editor. It's set up to help you. You can use like we did with HTML in the beginning, you can use a text editor. You can use, write Notepad. But if you use a editor that's written for programming languages, it'll help with syntax and catching things. Now, Genie Programmer is great as another great one. It's a more generic one, not so much just Java. For younger students, I would really suggest Greenfoot. All right. Now, for both Mathematica and Wolfram are for technical computing. Really not going to use a lot here. Though it's good to know it's fairly expensive software they give away for free. And what it does is it's a lot of mathematics and computational principles to solve industrial problems. What's cool about that is it's more liable to understand a question of, hey, rank African countries in terms of checking accounts. All right. What in America we don't realize is right now Africa is booming and so are their checking accounts. So one of the ways you see Africa booming is how many people are starting to set up checking accounts. And for example, they use their cell phones to do all their banking. So if you think about that, it's actually kind of intriguing because they've jumped around a lot of infrastructure. Like we look around here, we have all these telephones and telephone power. They've just skipped that. They've just gone all the cellular. And Mathematica has got a notebook interface for Wolfram, and Wolfram is just command line interface. So they're really the same program, just Mathematica has a nice outside screen for it. Okay. Node-RED is used for people that want to hook up the Internet of Things. Remember how we always talk about that? How we always... Internet of Things means I saw a number one times there are more IP addresses. I guess there's 3 IP addresses for every proton on this planet. So everything's connecting to each other. Some ways it's really a great thing, some things not so great. We'll talk later as we get through this. Imagine you'd see things like hooking up the Internet of Things on cows, so farmers can every day document the life, how their cows are doing, how's the health of the cow. You know, they can walk out in their field, but this data is coming in, temperature of the cow. For example, body temperature tells you, hey, is the body temperature in range or is the body temperature out? Oh my gosh, the cow's overheated. Well, do we need to get water or is it getting sick, right? That kind of thing. That's cool, and we're starting to use it, and that's positive, but also connecting everything. We have all these appliances hooked up to the internet, and somebody hacked those and really did some malicious work on those. So we've got to work our way through what we like to do and what we don't like to do with it. I guess maybe that's what I like to do is, I'm sorry, that's poor wording. We need to be cautious and judicious of how we do this. All right, Python 2, Python 3, popular text bank languages. We're going to go on through. Python 2 was the old one, and Python 3 is the new version. This is how you don't handle migrating languages. Python 2 is there. Python 3 came out. People didn't like Python 3. They stayed with Python 2 and created a lot of a lot of issues. And they have not been able to get over there. So they've not really been able to quite clarify. So I think the future is Python 3. Let me see if anybody's got questions here. Okay. Okay, great. Good. I would say for what we're going to play with is going to be Python 3. So Python, just make sure you can do Python 2. Just make sure you know when you're programming something as a Python 2 as a Python 3. All right, here's Sonic Pi. Learn programming by making music. That's kind of cool. And of course, we have Scratch. We jumped this here. How did I do that? It's Scratch, which is similar. Raspberry Pi uses a special version of Scratch, which is similar to Scratch 1.4. And if you know Pi, you can program in Scratch 2.0. Now they've moved back and forth on it. It much more looks like what they're doing. All right? So you've got Scratch. That's the next thing. You are high schoolers. I'm not going to bother with Scratch with you. In the past, we have. Okay? Any questions about those? All right? Now, we are going to learn Python. And it's a text-based language. And let me go over here. Wrong one there. And if we started going into Python, let me talk about Python here for a little bit. We're switching up now. Now we're going to talk about Python, but then we're going to go to something called CodeCombat. All right? That's an old slide. All right, Python. You can make it act like a calculator. In other words, it's got decimal points and numbers. You can multiply things, You can make it as a word processor. When we're talking about that, we're talking about strings and words and letters. And they have little functions, which are, think, mini programs. Okay, now, here is an example of it, but we're not going to go there quite yet. But you're going to see that we go in here, we start writing all this broad text down here, which a little bit in the beginning may be a little intimidating. But we'll get it. It does use white space quite a bit. And the way we're going to do it is we're going to go to particular favorite, CodeCombat. And this is it. We've been using CodeCombat from early on. So what I would like you all to do is you're going to go ahead and click on and load up CodeCombat. Now, let me show you this. When we go to CodeCombat, I'll put it over here for everybody. I don't want you paying for anything. So don't play anything for this. So just go to Code Combat, unless you decide later that you really like it and you want to learn a lot more. They're good guys. Just go to Play Now for today. So everybody go to Code Combat, Play Now. Let's go up here. I'm going to hide your questions. Attendees. Raise your hand once you get to this point right here. Again, for some of you, you're going to go, oh my gosh, we've done this. But for a bunch, you've not. And it's a good thing to practice. And we're going to use this to work with that Sense hat, that's Raspberry Pi hat that you guys have got. We're going to do it in Python, so that's what I want to show you that. Also, I didn't show it on those selection of classes. There's a simulator now on the Raspberry Pi for the hat. Okay, now let's go ahead and play now. Go to Play Now, and you're going to play. I want you to play Cathars Dungeon. Okay. All right. And this is where you're going to go on this. Now, let's talk about the different parts of this. We're going to come in here. See, that's Code Combat Premium if you want to buy it. There's items, heroes, etc. So, gems into the basic syntax.
For the win!
Okay. Make sure you can change your hero right here.
For the win!
And you can pick anybody you want. And make sure we're doing Python. That's the only thing I really want to show you. You can pick anybody else. I'll just go with her. All right? And then, so everybody pick your character. Raise your hand once you've done that. We'll take a few moments here and give everybody a chance. All right, raise your hands, guys, once you've got it. Oh, my goodness gracious. Let's see what's going on here. Okay. Folks, can you see me? Can you hear me now? Put your hands down. I'm going to put your hands down. Can you all hear me? Raise your hand if you can hear me. We had a little bit of a technical problem there. All right, great. I'm not sure what's going on there. I'm all plugged in. It says it's charging, so let's keep our fingers crossed. Okay, so what you do is this stuff is locked. You can't get to it, like any game. And we're going to equip. What the equipment really does is it gives you, so there's the leather belt. All right, adds some extra health there to you, which really basically gives you more code. So let's go ahead. We're playing.
Code Combat.
Collected gem.
Move right.
All right, now let's start the level. Goals: avoid the spikes, start level. Here we go. So we're just going to have, here she is, move right, get the gem, and then go down. So you hit run, watch what it does.
Move right.
All right.
Type a move down command on line 4.
Now I go to hero move down.
Move right. Move
Then
down.
down. Okay. Now we can do hero move up.
Move right. Move down. Move up.
You gotta go a little bit higher. Move up. On.
Move right. Move down.
Remember, it
Move
goes
up.
exactly
Move
the code. We don't want to hit the spikes. We're gonna do hero move right.
Move right. Move down. Move up. Move up. Move right.
All right, so now we're done. Goals. All right, so you gain experience. And what you're going to start doing, you can create a free account to save this. If you want to save it, great. Make sure it's a free account. Then we're going on to the next one. So I'm going to pull you up. But I think you start to see it's going to walk you through each one of these steps. Remember, as you're working on this, and we're going to go back and look at some of these, the computer program does exactly what you tell it to. It doesn't do what you want. It does what you tell it to do. And sometimes that's not the same thing. So you have to be really careful and take your time on that. So did everybody get through that first level? Raise your hand once you've done it. Good job, folks. All right, Grayson, Cohen, Mateo, have you dropped off or you just haven't done it yet? Okay, we got some more people coming. Good. All right, well done, folks. Now, let me go back up here. So, as you work through there, you're going to get more and more code. So let me go through here. So, CodeCraft's fun again. It's a real based learning. We help write this. Okay. This code you're writing uses real syntax, meaning the lines you write solve the puzzles in real lines of code, just so you know that. All right. This is a big sign up. You plan as anonymous. You can get a free account, but don't do it. We're going to be using Python. Make sure we're not using Java. JavaScript is not the same thing as Java. They wanted a script for HTML accounts, and everybody knew what Java was. So instead of giving it a new name, they called it JavaScript, even though it wasn't based on Java. All right. Kind of reminds me, there used to be a database program called DBase, and it was DBase 2 because they knew everybody thought if it was DBase 1, it would have a lot of bugs. I'm not making that up. All right. All right, and there's campaigns. Let's try this Githar Dungeon manually. That's the one we want to do. Python again. We chose her, and sometimes they have the shoes too with them. They have move down, move left, self move right, move up. And they move down at just that. Now, here's the thing. Person is the object. All right, and there's the method, move down. So that moves down. The person moves left, person moves right, moves over. Those methods are like functions, but associated with a specific object. So in other words, self is you run into the gang, you're a hero. Move down is a method that's only associated with yourself. If there was a book, it might not have that move down method because books generally don't run around. And then you have functions are named reusable sequence of code. You know, print, input. You know, if on edge bounds, move 10 steps are all examples of functions. Okay. If on edge bounce, we have that in Scratch. If touching edge, bounce in that direction. So this is a function that's built into Scratch, which many of you played with, but it's really these two lines. And so instead of having 5 blocks, you just have 1. Sorry, we got this game going on here. So if the methods are associated with a specific object, what does the object move down? Object's the person, by a period, and notice there's a parentheses there. Let me go ahead and see if I can do something about this sound. Good. Sorry. And this is true. Now, these are methods specific to this game, but the idea is that if you understand how to make this gameplay, you'll be able to use Python to do other things like use Raspberry Pi and use sensors and whatnot. The object here is self, which refers to your player. Self is actually a variable that stores information about your player, like their location. In Code Combat, the boots allow us to use above these methods. Self move down, self move left, self move right, self move up. As the game continues, we get more armor weapons that will give you access to additional methods. In fact, I'm going to stop here a second. Let's just see how my pacing's doing. You guys should tell me that right now so I know if I'm going too fast or not. Okay, great. We got 8%. I'm going to close the 5, 4, 3, 2, 1. With 87% in, we had 9.2 with 8% saying I'm going a little too fast. So I'll make sure I don't go any faster, and we'll take it from there, and I'm certainly going to help you. Let me hide the results, something I sometimes forget to do. All right. Now, in Python, you use import line to import libraries or modules. These are bundles of functions for you to use. So that's something. So in case you're wondering, hey, where do we get these methods? It's libraries or modules. We bring them in. And the reason why I bring this up is think about it. If we have a language called Python, people are going to use it for lots of different reasons. So if you added every capability to Python, your language get really big, really heavy, the program really expand. By using libraries or modules, you're allowed to bring in special features that just you need. So in this video game, they have special functions to run a character around. You might, down the road, we're going to see that we have special functions for the Raspberry Pi, some of the things we do with that. All right, you use this method, and this was the old, you hit the run, we do the move down, left, right, up, or down. Okay, and you can, I'm not really care because we're going to do a little bit different. And there it is. So you're going to run down to these, and these, just what we did. Okay. Notice that we moved right, move down, move up, move right. Okay. Let me bring up the questions, just make sure. Oh, someone asked what events do I host for Science Olympiad. Amazing Mechatronics from middle school, which is Raspberry Pi. And then I'm doing something called Pro Gamers, and it's little kids programming in Scratch. It's going to be fun. Okay, Shadow Guard. Let's go through this one. I'm going to go back to get you guys to go pull on this. All right. Oh, don't tell me I just. Okay. I somehow jumped out of this. I didn't mean to do that. Sorry, guys. All right. Again, we're going to start the level. We just did this. All right. Now, what we're going to do is don't run into the spikes, collect all gems, don't let the ogres see you. So you've got to do this in such a way. So we can go to hero moves right. And that's what that function is telling you. That's the method. So hero, that's you. I'm purposely got the sound down though. Moves right. And since I wanted to do it again, I'm going to hit hero. Moves right again because I don't want the ogres to see me. So I'll run it. Watch what happens. Got that one? Oh no. Oh no. All right. Okay. Okay, so he saw us. All right. Now, go ahead and see if you can figure out what to do. Go ahead and play. There's also hints right here. So you could go here, couldn't you? And up and down so he never sees you. Go ahead and try, folks. Let me know once you have it. Okay. Let me look at some questions while everybody works on this. Something's wrong. It's not working. What's not working? Okay, I'm good there. It's not wrong. Make sure you're in Chrome. Good. You got a comment from way back? Okay, good. There's a hint up there. So see what you need to do. Okay. Let me know once, raise your hand once you've got it figured out, and then we will raise your hand once you've gotten it to work. I'll wait for you right here. All right. Nice job. We have good attendance. That's really important. And I really, as people are working on this, I'm really excited to see you guys see these perpetual mirrors. We've been working on them. They look really, it looks really cool. Let us know, Mateo, Laura, Harry, Hannah, once you've got it, write to me so I know. Okay, great. So people go. So that way we know. All right. So if I go to this one, it's basically, I'm going to move, I'm going to move right, then up, then right, move down and over, and the ogre will never see me. Yes. All right. Next one, let's go over here. Go back in hanger. All right. Let's try it again. So move right. So it'll make me, let me go up. Let me look at what I made earlier. Move up, move up, right, down, right. Move up. Arrow move right. Again, the order matters, sequence matters in programming. Then arrow move down. And this is like we talked about specific editors and Raspberry Pi. That's what they do. They warn you when you're about to type something wrong. Let's see what this does. Go here, 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 here. Oh, went too far. Oh no. I needed to move down. So here, move. Let's try it again. Here, here, here. Nobody sees me. Oh, still went too far. I need to move this down. I moved that in the wrong order. Whoops. That's funny. Okay. Make this move right. Let's try that. So here's my little girl. My character going down, down, right, right, right. Yay, done. All right. Factory. Clean code, no code, experience, got all these, a new item, a simple sword. And then you contain. Now you really can't save your progress. Well, I did not want to do that, so I just popped out by accident. So, and so you can create an account. Just make sure it's not, do not pay anything for the accounts, guys. So as we go through these, let me pop up this just for the sake of, I got to log into my old account. I'm a teacher, so let's look at this. And this way you guys can play with these. You know, enemy mine, avoid the fire traps and get the gems. Remember that functions are names, reusable sequences of code. Inside those functions are things called arguments, and they pass it in there. So you can say self move right to is the same thing as saying that twice. Okay? We as engineers and programmers want to be efficient, so anything that will help us do it better, we want to make it efficient, all right? In that way, you can run things over there. So you can do something like, well, I'll tell you what, you guys do it. Raise your hand when you get to the next one, all right? I'm gonna go to questions, see if there's any questions here. Cohen, is it working any better for you? Let me see. When you get this, let me know. Raise your hand. We go to questions. Folks, raise your hand if, all right, let me see how you're doing. Great. Excellent. So most people have gotten it. Good job. Okay. So self move right is the same, which saves us a lot of time instead of repeating right 3 times. Move up, move right, move down 3 times. All right. See how much more that allows you to do. Using arguments allow you to reduce your lines of code considerably. Okay. And these will allow you to play your sequence or zoom out your call. That's the hero toolbar. We'll get a little bit more into that. This zooms it in case you can't see things. All right. Now, next one, true names. All right. Let's see how we're doing on time. Okay. Now, in this one, you're getting a new method. We've had move, down, left, right. This is self-attack target. So self, that's being your character, attack, and then you got to give it a target. So, and you can put your hand over this function, and you'll see this in a lot of programming editors that they help remind you what you need to do. Okay, pardon me. So, self-attack treg, self-attack, so attack the enemy treg twice. Self-attack treg. Notice the quote there. The attack method makes the hero attack a target unit. Action attack takes 5 seconds damage, gives you all those details. But here's what I really want is the parameters. So you can do target, object. You can also do things like, you can say target, self, find nearest enemy. So you don't even have to put down the person's name. You can, I think this is actually a better way to go most of the time when you do things. This says, hey, find the nearest enemy, attack said enemy, because it just assigned it to that variable. The most basic one is if there's a treg, attack it. Notice there's a quote. It's a string. When we use variables, generally we want literals, I should say, names, literally strings. We use a quotation, like we see treg, quote, self-attack treg. But as programmers, it's often better to use variables. So this way, we can only use these 2 lines of code if we're attacking a treg. Down here, it's find your nearest enemy, right? Assign it to the variable enemy and then attack it. Does that make sense? So this bit of code you can use with whatever monster or a person, as long as they're an enemy. This one, it's specific to treg. Now, there might be a reason you say, no, I just want treg, but a lot of times I like using code that allows me a lot of flexibility. I have to redo it. Okay. So defend against Brack and Treg, you must attack small ogres twice. Okay. So go ahead, try that bad boy. Raise your hand once you get it. Wow. Good job, folks. Kicking butt and taking names. Give everybody else a chance here. So let's go on to the next one. It looks like most people here are set to go. All right. Self move right, self attack back, self attack back, self move right, attack trag, and then move right 2. So as you can see in here, we added the parameter 2 for here, or we added strings right here. Strings are letters or words. Computers understand different kinds of variables. So integers and floating point numbers to characters, strings. And I can all do this in text Python, guys, in your Raspberry Pi, but to me, I think this is a little more interesting to do. So we talk about different kinds of variables, data types. There's an integer. Integer is just fancy way of saying it's just a whole number, like you think of that. There's where floating point is 4.0. Booleans are yes or no. Strings are the word for. So you can be all these things, right? Integers, great counting. When you're in the real world, we usually do have decimal points in the numbers. Not always, but many times. These names are a string, as I just mentioned. Okay, dodge the fireballs. And in this one, you're doing fire dancing, and we'll try to finish up with this one. Using a while loop. So we've learned about different data types. We learned sequence, the order in which these things go. We've learned about parameters that go inside our methods or our functions. We have our methods, and we have functions. Okay, so here's what this says. Use a while loop to repeat something forever like this. While true, self move left. This will happen over and over again. Whenever this is true, move myself to the left. And remember, while true is in that book. And this is just read only. Here's a while true command. Looping through as while true, move right, move down, move right, move up. All right. While true, enemy, find the nearest enemy. If an enemy, attack the enemy. That will allow you to keep attacking them. So this is now looping. This is doing two things here. It's actually doing an if-then statement. If I find an enemy, attacks that enemy. And it's also showing you looping. And it's showing you sequences. And honestly, those are the three basics of all programming languages. Sequence is important. You've got to be able to do if-then. And you most certainly have to loop things. And if you can do that in one language, you just spend a lot of time figuring out how you do it in other languages. It's a lot more nuance in MATLAB and stuff that we're going to use down the road. It's a little bit different, but okay. Loops are used to repeat a sequence of code, either a set number of times or forever until a condition is false. So repeat 10 or repeat until something is true or false. Code normally executes in order it's written. Loops let you repeat a block of code multiple times. Use the tab or 4 spaces and then to move all the lines under the loop. This is important and something special to Python. It uses the white space. C++ does not. We're going to go through this one more time. So while true, move in 4 lines, self move right, self move left. Notice it's that 4 lines over. Go back up here. Self move down, move left, right, up, while true. And there we go. Okay. Loops are used, we just said that. So fire dancing could be something like this. So look what this loop does for you. That's what we're really just going to finish up with because we're about out of time. While true, move to the right, and then move to the left. So we move right, move left, move right, move left, move right. This is so much faster. And that's the power of looping. And when we use our Arduinos, we use our Raspberry, you have to have loops so you can keep the program running over and over again. Because remember, if there's no loop, this will run all the way down. And then once it gets to that last line, it stops running, where a loop runs on indefinitely. Okay? Sometimes we don't want what's called a perpetual loop, but sometimes we absolutely need it. So, again, same kind of idea in avoiding the lightning beam. All right, just remind you, this Thursday, I believe we have a lab, but I do know we have one Saturday. Let me check on there, see if we have the calendar on there. Let me check on Thursday's lab because we had one last Tuesday. Bear with me here. Yep, we have a high school lab. Saturday we have a lab for high schoolers. And then the following week will be a 7th and 8th grade lab. So yes, we have a lab Thursday. We have a lab, remember, it's 7 to 9 Thursday, and we have it for Saturday. And we'll do our digital portfolios then too. Okay, any questions? We go back over here to questions. All right. So if you want, just for fun, you can create an account. Again, if you've created an account, great. Make sure it's a free account. We'll go through Tom tutorial. We'll talk about where we go next with this on Python. We want to show you this stuff through Code Combat. We think it's more interesting than if I just do a text game necessarily right off the bat in Python. All right, let me do some polls while we're still here. What'd you think of the webinar? I mean, this is something you can share with your teachers or your homeschooling folks who are teaching you programming. It's a great way to do this. All right. 87% voted. 5, 4, 3, 2, 1. 85% said always show these. It was great. 15% was okay. All right. Real quick. Coming to the last webinar. Did you go last Wednesday? It's important you go to these webinars, folks. And for the most part, everybody's going. So really good job. We got 73% voted. We need a few more people to vote. All right, 80% voted. 5, 4, 3, 2, 1. Good job. Most of you are coming. Keep that up. Really important as we keep going through this. You're going to get a lot more out of the class. And it's been a while. Well, we had a lab. Some of us had a lab Thursday. Some Tuesday. I think you're going to enjoy the infinity mirrors, folks. A lot of woodworking and some electronics now. Okay? 5, 4. We got 67%. Can we get some more people on the last lab? All right. Close poll. Share results. And most people like the labs. We're glad to hear it. We're going to keep doing cool labs and make sure you're involved. All right. It's about that time right now. We're going to go ahead. I promised everybody this year I would make it a point not to go late, because I know you all have so much going on. Look forward to seeing you this week, and we'll talk later. All right? Bye-bye. Have a great evening. I don't know why, but it's not. Trying to shut this off, folks. Oh, there it is.